Welcome, chemistry champion. My name is Omotola Fayomi. If you are here, you are serious about acing JAMB. I love that energy. In the next few minutes, we are going to completely smash stoichiometry and Mole concept, one of the biggest mark-carrying topics in JAMB chemistry. And this is your rapid fire, no fluff, exam-focused revision. Stay sharp, stay focused. Your grade start right here. Let's get into it. So what is a mole? A mole is simply a counting unit. Like a dozen mean 12, a mole means 6.02 times 10 to the power 23. This is Avogadro's number. Write this down. Na, which is mole, which is Avogadro's number, is 6.02 times 10 to the power 23. 1 mole of anything, whether it's water molecules, sodium atoms, or carbon dioxide, always contain exactly 6.02 times 10 raised to the power 23 particles. 1 mole of water is 18 grams and contains 6.02 times 10 to 23 molecules. 1 mole of sodium is 23. 1 mole of CO2 is 44 grams. The mole connects mass, something we can measure, to the number of particles, something impossible to count directly. That is the genius of stoichiometry. Here it is, the most important formula in all stoichiometry. N equals m divided by m. N is the number of moles, m is the mass in grams, capital M is the molar mass in gram per mole. JAMB will throw this at you in so many ways, but it always comes back to this one formula. Let's use it. How many moles are in 88 grams of CO2? First, find capital M, that's M of CO2. Carbon is 12, oxygen is 16, and there are 2 oxygens. So capital M equals 12 plus 2 times 16, which is 44 grams per mole. Now, N, that's small n, equals 88 divided by 44, which is 2 moles. Done. And remember, this formula rearranges. Mass equals N times M, and M, that's capital M, equals mass divided by moles. One formula, 3 versions. Master it. Before you can use N equals M over M, you need to calculate M, that's the molar mass. It's simple. Just add up all atomic masses multiplied by how many of each atom there are. Your JAMB atomic masses: hydrogen is 1, carbon is 12, nitrogen is 14, oxygen is 16, sodium is 23, sulfur is 32, chlorine is 35.5, calcium is 40. Memorize this. Water, H2O, that's 2 times 1 plus 16 equals 18 grams per mole. Sodium chloride, NaCl, 23 plus 35.5 equals 58.5 grams per mole. Sulfuric acid, H2SO4, that's then 2 plus 32 plus 4 times 16, that's 98 grams per mole. Calcium carbonate, that's then CaCO3, that's 40 plus 12 plus 3 times 16, that's 100 grams per mole. These 4 compounds show up in JAMB constantly. Know their molar masses by heart. Now we combine the 2 formulas. N, that's the capital N, equals N times Na, where Na is Avogadro's number. That's 6.02 times 10 raised to power 23. Find the moles first using N equals M over M. That's mass over molar mass. Then multiply by Avogadro's number. Example is how many atoms in 46 grams of sodium. Molar mass of sodium is 23 grams per mole. So N, which is the number of mole, equals 46 divided by 23. That's 2 moles. Now, N equals 2 times 6.02 times 10 to the power 23, which gives us 1.204 times 10 to the power 24 atoms. JAMB always asks this in 2 steps. First, find the moles, then multiply by Avogadro's number, and always express your answer in scientific notation. That is the JAMB star. Here is a beautiful JAMB gift. At standard temperature and pressure, STP, 1 mole of any gas occupies exactly 22.4 dm cube. It doesn't matter if it's oxygen, nitrogen, carbon dioxide, or ammonia. 1 mole of any gas at STP is always 22.4 dm cube. That's the molar volume. At room temperature and pressure, RTP, it's 24 dm cube. The formula is simple. Volume equals moles times 22.4. Example is this: calcium carbonate decomposes to give carbon dioxide, and calcium oxide. From 10 grams of calcium carbonate, the moles are 10 divided by 100, that's 0.1 moles. The equation is 1 to 1. So 0.1 mole of CO2 are produced. Volume equals 0.1 times 22.4. That gives 2.24 dm cube. Beautiful. JAMB will tell you whether to use STP or RTP. Read the question carefully. Now, the empirical formula is the simplest whole number ratio of atom in a compound, and finding it is a four-step process that JAMB tests over and over again. Step 1, write the percentage composition of each element. Step 2, divide each percentage by the element's atomic mass. Step 3, divide all the answers by the smallest one. Step 4, round to whole number. Let me show you. A compound has 40% carbon, 6.7% hydrogen, and 53.3% oxygen. Carbon 40 divided by 12 gives 3.33. Hydrogen 6.7 divided by 1, that gives 6.7. Oxygen 53.3 divided by 16 gives 3.33. Now divide everything by the smallest, and which is 3.33. Carbon will give 1, hydrogen 2, oxygen 1. The empirical formula is CH2O. Special tips is that if you get 1.5, multiply everything by 2. If you get 1.33, multiply by 3. Always make them to be a whole number. Now, the empirical formula gives the simplest ratio, but the molecular formula gives the actual formula. To go from empirical formula to molecular, you need the actual molar mass. The formula is N equals molar mass divided by empirical formula mass. Then multiply the empirical formula by N. Example is that our empirical formula that we just got is CH2O with a mass of 30. If the actual molar mass is 180, then N equals 180 divided by 30, and that gives us 6. So the molecular formula is CH2O times 6, giving C6H12O6. That is glucose, the sugar that powers our brain right now. Beautiful. JAMB loves this question because it tests both empirical formula and this bridge calculation. Always remember, the molecular formula is a whole number multiple of the empirical formula. Always. Now, stoichiometry, which is the heart of using balanced chemical equation to calculate amounts, and this is key in understanding mole ratios. Look at this equation. Nitrogen gas plus hydrogen gas, which has 3 moles, gives 2 ammonia. The ratio is 1 to 3 to 2. That means 1 mole of nitrogen reacts with 3 moles of hydrogen to give 2 moles of ammonia. JAMB loves the 4-step approach, and these are: step 1, balance the equation. Step 2, convert given mass to moles. Step 3, apply the mole ratio from the equation. Step 4, convert back to mass if needed. Let me show you. Now, 5 grams of calcium carbonate decomposes. M of that molecular mass of calcium carbonate is 100. So moles equals 5 divided by 100. That's 0.05 moles. The equation gives a 1-to-1 ratio. So 0.05 moles of calcium oxide forms. Mass of CaO, which is calcium oxide, that is it. So 0.05 times 56. That's how to get the mass of calcium oxide. 0.05 times 56. Then the molar mass of calcium oxide, that is 56. And then you will now give 2.8 grams. And that's the answer. 4 steps every time. Now, percentage composition asks what percentage of a compound's mass comes from each element. The formula is percentage equals atomic mass times number of atoms divided by molar mass times 100. Quick example. In H2SO4, that's sulfuric acid, with molar mass of 98, the percentage of hydrogen is 2 times 1 over 98 times 100. That's just 2.04%. The percentage of nitrogen in ammonia, Na3, molar mass 17, is 14 over 17 times 100. That's 82.4%. Urea, the fertilizer that we used, with formula NH2 into bracket 2 CO, has molar mass of 60. Percentage of nitrogen is 2 times 14 over 60 times 100. That's 46.7. JAMB loves urea and fertilizer questions. And this is a tip that you need to know. Always check your answer by verifying all percentages hard to 100%. Concentration tells us how many moles of solute are dissolved in 1 dm cube of solution. C equals N divided by V, where C is in mole per dm cube, V must be in dm cube. This is the number one JAMB trap in this topic, forgetting to convert. 500 cm cube divided by 1000, that's 0.5 dm cube. 250 cm cube, that's 0.25 dm cube. Let's do the example. 8 grams of sodium hydroxide dissolved in 500 cm cube of water. Molar mass of sodium hydroxide 23 plus 16 plus 1 equals 40 grams per mole. Then moles, 8 divided by 40 equals 0.2 moles. Volume, 500 divided by 1000, that equals 0.5 dm cube. Concentration, 0.2 divided by 0.5 equals 0.4 mole per dm cube. Don't let that unit conversion cost you marks. Now pause. This is your JAMB moment. I'm going to give you 5 seconds to answer this question. Comment the option that you think is correct under this video in the comment section. The question is, what is the mass of 0.5 mole of sulfuric acid H2SO4? The molar mass of H2SO4 is 98 grams per mole. Ready. Your options are A, 19.6 grams, B, 49 grams, C, 98 grams, D, 196 grams. Right now, the answer is B, 49 grams. And here is how we got the answer. We need mass, not moles. So we rearrange mass equals N times M. Mass equals 0.5 times 98, which is 46 grams. Perfect. If you got that right, excellent. You are understanding stoichiometry. If you didn't, no worries. That's exactly why we practice. Now you know. And here it is, your complete JAMB stoichiometry formula kit. Screenshot this right now. Share it with every chemistry student you know. You have N equals M over M for moles, for mass, for mole. N, that's capital letter N, equals N times 6.02 times 10 to the power 23 for particle count. V equals N times 22.4 for gas volume at STP. C equals N over V for concentration. Percentage equals AR times atoms over MR times 100. And the empirical formula to molecular formula pathway. This cheat sheet covers every stoichiometry question JAMB has ever asked. Screenshot, save, share, and use it when you study. Yes, you did it in few minutes. 9 key topics, and you just revised the entire stoichiometry and Mole concept unit. That is incredible. Give yourself a round of applause. And if this video helped you, please hit the like button right now. It takes 1 second to do that, and it helps more students to find this content. Subscribe and hit the bell so you never miss another JAMB chemistry blitz. Share this with your classmates and with others that will need it on your WhatsApp group, your study partner. Let's help everyone score an A. And comment below, what is your JAMB target score? I read every single comment. Remember this, you are not just studying for an exam, you are building a future. The JAMB chemistry A is yours to claim. Now go and claim it. See you in the next video. God bless you. Morph. Cheers.